Last time we finished off talking about how you pick the value of k for the k-means algorithm. Right? So remember, you have to pre-specify the value of k, and we talked about why it is difficult to pick it automatically. It's because what the clustering is trying to do, it's trying to minimize the distance within the clusters, the variance of points around their centroids. And that distance is going to get smaller and smaller and smaller as you add more cluster centroids. So it's going to be maximized when you have as many cluster centroids as you have data points, where every data point is going to be in its own separate little cluster. So the distance, the variance within clusters, what k-means is trying to optimize, by itself, it is not a useful measure for telling you whether you have a good clustering or not. For a fixed value of k, it's a decent measure, meaning a clustering. So if you set k to a fixed value, a clustering that has a smaller variance will look better. The clusters will be tighter, but in general, you cannot use it to decide how good your clustering is. And it turns out that in general, it's really hard to figure out if your clustering is any good. So the question of how do you evaluate a clustering? You built a clustering algorithm, it can cluster data into groups. Are those groups any good? That's a question that you want to ask, and that turns out to be a really hard question to answer. There isn't a straightforward way to evaluate clustering algorithms. We'll talk about two large families of attempts at evaluating clustering. So the first one is extrinsic. So extrinsic evaluation, it's where you take some algorithm and you don't evaluate it directly, you try to see if it's useful for solving another task. Right? Does it help you solve some other task that you typically solve with another algorithm? So an example of this would be maybe you want to classify images and you want to represent images in some way. So you're going to be classifying images as to whether they contain a person or not. So you could use clustering to represent the images. So instead of using pixels, or instead of using some other representation, you could use clustering as an intermediate step to convert the image features into some other kind of features, and then train a classifier and see if you get better accuracy this way. Right? Or you could do it in a different way. You could maybe take your data set, use k-means clustering to separate it into several different groups, and then train a separate classifier within each group. Right? Maybe hoping that all the images in one group, they all look like each other, so hopefully classification will be easy in that more homogeneous set of images, and then you'll have a separate classifier for each cluster. Right? So you could do it that way, and then compare it to classification without using clustering. So that's extrinsic evaluation of clustering. You have an external algorithm, classifier, and you run it with clustering or without clustering in the pipeline, and you see which way is better. So that's extrinsic evaluation. You're trying to see if clustering is useful for some other task, for classification in this case. Intrinsic is you're trying to see if the clustering is useful in and of itself, right? So the clusters, are they good by itself? Not in terms of using them for some other task, but are they good by themselves? And there you can have either qualitative or quantitative methods. So remember, you're doing the clustering. You're not predicting anything specific. You're maybe trying to understand the makeup of the data or the structure of the data. So if clustering helps you understand something about your data, that would be a qualitative type of evaluation. Right? You can't put a number on that. It either helps you uncover some patterns or not. You could try to evaluate numerically if you had some examples to compare to. So cases where you could do that, for example, if you really have a classification task, so if you're maybe trying to classify bitmaps into digits, it's a classification task, you could choose to solve this task using an unsupervised method, like clustering. So you could take a bunch of bitmaps, run k-means with k equals to 10, it would produce 10 clusters in a completely unsupervised way, and then you could see how well do those 10 clusters map up to the 10 classes that you have in the labeled data. So that's another way in which you could evaluate clustering. It's a little bit convoluted, because what you're doing is you're taking a supervised task, classification, which you should be solving using a classifier, and you're turning it into an unsupervised task for some reason. And your accuracy is going to be horrible, but at least you can evaluate it this way. Right. If you can't do that, for some reason, if you don't have an actual notion of classes, you can get human judgments and use those to evaluate the quality of the clustering. And there what you typically do is you use humans to label individual pairs in your data. So you can't ask a human annotator to cluster a data set for you, it's too labor intensive, but you can give them examples of pairs and ask them, this instance A and instance B, should they be in the same cluster or not? And then you get a bunch of those judgments from users, and you see how well they map to what your system is producing. Is your system putting the right pairs into the same cluster and the wrong pairs into different clusters? So we're going to talk about all three of those options, about extrinsic use of k-means and about using intrinsic with both classes and with human judgments.